Okay, great. Hello, everybody. Thank you for joining us today. Today's webinar is going to go over the WRLD Unity SDK version 0.8. This is certainly the biggest release we've done on Unity since we made the Unity SDK available a few years ago. So we're very excited to share with you a number of different things today. So for those joining us, if you're using the WRLD Unity SDK today, thank you so much. We really appreciate your adoption of it and are quite grateful. If you're looking at evaluating the SDK today, we're happy to answer any of your questions and look for your support. So hopefully you'll get a good flavor of what the SDK can actually achieve. So to start off with, just to introduce myself, my name is Fazan Gori. I've been CEO and worlding since 2017. One of my key focuses was actually to bring this SDK to life. So excited to share with you where it's taken us and some of the developments along the way. Ian, if you want to go ahead and introduce yourself.
Hi everybody, my name's Ian Bethune. I'm head of software development here at WRLD, and as Faizan said, it's been a long time coming, this SDK, so I'm looking forward to sharing some of the work that the team have put into it in terms of new features.
Great, thank you, Ian. So to start off with, I will mention that we are recording this session and we will make it available on our YouTube channel and potentially other social media following this meeting. So if there's anyone else that you wanted to share it with, you'll be able to do that as well. Also, in terms of Q&A, we will have questions. You can, whilst we're going through the presentation, you can submit your questions into the Q&A window, and we will answer them once we get to the Q&A portion. And then we'll also open it up if people want to raise hands and ask questions there. So today the agenda is to give you a brief history of the WRLD Unity SDK. Secondly, we're going to show you some of the applications that WRLD Unity creators have made, and they really run the gamut here. Thirdly, we're going to go over the actual feature list of the new WRLD Unity SDK. Ian's going to walk you through some really great demos and tutorials on Unity. And then finally, we will start answering your questions. So with that, let me just start with giving you a brief history of the Unity SDK. So first, a 10,000-foot view on what WRLD does. So we have built a digital twin platform that really bridges the physical and digital worlds together. So you've got the physical world, and then you've got this digital twin layer, which is a semantically associated, geospatially accurate model of the world indoors and outdoors. So it's effectively a machine-readable layer of the outdoor and indoor environment. And thanks to having a digital twin layer, you're able to, as a developer, do a number of different things, such as really create a visualization layer. And then WRLD also offers a UI layer that developers can go implement directly in their application. And just like Unity, we are cross-platform. So it is truly a build once, deploy everywhere model. So that digital twin is then available for you on web, mobile, virtual, and augmented reality. So in terms of our history with Unity, it actually is very consistent with our history as a company. So the genesis of WRLD was really a few game developers getting together and wanting to build a real world version of Grand Theft Auto. So you can actually see here, this is an early game being built in the WRLD environment at the time. And the vision was to be able to take all the real streets in the world, all the real buildings in the world, and create experiences like a Grand Theft Auto using that world. So of course, we've gone a few pivots from there. But where it's landed us is really now we offer a cross-platform SDK, not only available on Unity, but also available on other platforms, really geared at both enterprise and games. And it's interesting, if you look at Unity in the last few years, has very much gone into the enterprise segment from starting as a genesis in the game segment. So we've sort of mimicked that own history with ourselves. So in 2017, we launched the Unity SDK, and we saw many creators use the platform and experimented ways that we never thought possible. So here we see a creator who's playing around in HTC Vive and hovering over the Statue of Liberty. In 2018, one of the key use cases for WRLD is smart buildings and indoor maps. So we did in 2018 begin to offer the ability to access indoor maps within the Unity platform. And you will see some of the evolution of where that's taken us today as we talk about the new SDK. So moving on, I'm going to now show you a few videos that show some different applications and experiences that have been built on the WRLD Unity SDK. And like the Unity community, they really run the gamut from single hobbyist type developers, building experiences on top of WRLD, to large development studios and teams building some pretty interesting applications. So with that, I'm going to start by first showing you Udacity Universe. This is a massive shared simulation environment that Udacity, the online learning platform, had built to help their students with flying and autonomous vehicle simulations. And then following that, actually, this is a little bit of a prelude to what Ian's going to go over today when he shows you some of the exciting work we've done on ML agents visualization using the WRLD platform. So one step here. All right.
Udacity Universe is a massive shared simulation environment that allows students to tackle problems at scale collaboratively together. When we're talking about a massive virtual world, it means that virtually anything is possible. The flying car students will control aerial vehicles, the self-driving car students will control self-driving cars.
5 years from now, many of the transportation actions that we require will be performed by an autonomous vehicle, whether it's flying or it's on the ground, or students will be able to build large scalable systems and try them out, experience what works, what doesn't. You will learn not just how to control an individual vehicle, but actually many vehicles, all performing different tasks and doing it in an efficient, goal-directed way.
Help us build the future with Udacity Universe and sign up for the self-driving car program or flying car program now.
Yeah, very cool stuff. The next one that I'm going to run you through is an application that actually was built, started being built in 2018. We hosted a WRLD Unity Challenge where we held a contest for Unity creators to build interesting applications, whether in games or enterprise using the WRLD platform. And this developer, Kenny Hansen, did a really fantastic job and created a HTC Vive experience that's available on the Steam VR store that really gives you the feeling of flight and freedom as a bird flying through the WRLD environment. So this is Wing VR. Sorry, 1 second. highly recommended if you have an HTC Vive. And I think Kenny is planning on bringing it to the Quest soon too, if you've got any of those devices. So next up. Just a sec here. The next up is one of our partners, Smart City. They've done some very interesting work. Effectively, what they're doing is combining location-based gaming, a la Pokemon Go, and plugging it in with shopping experiences. So if you're familiar with the Dubai Mall, which is, I think, probably the biggest mall in the world, or one of the biggest malls in the world, it can be quite overwhelming. So they've created an application that puts together navigation, avatars, discounts, and has the app even features little helpers there, virtual avatars that will help you navigate through the mall and find what you're looking for. So here is Smart City. Great, and that app is actually available in the App Store today. So please give it a try. It's available on both the Play Store and on iOS. Smart City is the name. So the next thing I'm going to show you is actually one that we built internally in WRLD. It's a little long, so I'll skip a little bit about it. But really, I wanted to show effectively how you can build tabletop AR experiences in the WRLD environment. And then later on, actually, Ian's going to show the samples that we have available in AR. But what's exciting is that we actually built this experience a few years ago, and a lot of the use cases we're talking about, we've seen Unity creators actually build around. So here is my digital avatar actually running in a tabletop WRLD environment.
Hello and welcome to WRLD. This is my digital twin. We're coming live from Dundee, Scotland, where our platform team is based out of. And today, we're going to talk about what digital twins enable.
I'll just skip a little bit here.
Power the future of workplaces. As buildings become more connected, our workplaces will be more productive and attuned to employee satisfaction. Today, we can help companies understand space utilization so they can make their buildings more efficient. Tomorrow, digital twins will allow us to be at many offices at once. Digital twins will create new hospitality experiences that will connect properties with their customers. Today, our digital twin allows hotel guests to order drinks on demand wherever they are in the property. Tomorrow, hotels will utilize mixed reality augmentations to drive guests to try more services. Today, our digital twin is helping consumers navigate to retailers and drive footfall for malls. Tomorrow, digital twins will allow retailers to create incentives tied to Pokemon Go-like experiences that will reassert the importance of physical retail.
Yeah, so that is what we wanted to really demonstrate there, is that there's nothing stopping you to actually link that up to real-time data, whether it's indoor positioning systems or other types of indoor data sets. So imagine you can almost have a real-world virtual sim city on a tabletop augmented reality experience. It's pretty interesting to think about, and certainly we're hoping that somebody does link it up to some type of real-time data sets. Okay, so Ian, I'm going to hand it over to you, and you can walk us through the new SDK.
All right, thanks, Fazan. Hello, everybody. As we said at the beginning, we're going to now kind of dive into the new features and functionality that's available in version 0.8 of the WRLD Unity SDK. So first up, the most major revamp of the SDK is to introduce support for the recent versions of the Unity editor. So now you can bring WRLD into your Unity projects in the 2019 and 2020 versions of the Unity environment. So that's all now bang up to date. We are continually also expanding our map coverage at WRLD. So a few years ago, we first built out Western Europe, and we made it available on some of our other platforms. But we're now bringing that into the Unity SDK by default. So if you're an existing user and added in the Western Europe map coverage manually, you won't have to do that. Or if you're starting afresh with WRLD, with the Unity SDK, then you'll get all of the Western Europe map coverage included. So you can build your mapping applications out in that region. So the Unity SDK provides a whole bunch of APIs which you can use as a developer to help build your Unity apps. So some of the more important ones that we've recently introduced, we have our props API. So essentially what that allows you to do is to introduce 3D models, for example, pieces of furniture or equipment into your indoor maps. So you can start to populate those, make them look more realistic, but also more importantly, you can start to represent real world objects and their status. So for example, it would become easy to build a desk booking application where you can show desks in red or green highlight, and depending on their state and whether they're booked or whether they're available. Or if you have pieces of critical equipment in your buildings that you want to be able to highlight the state of, you can do that as well using our props and highlighting APIs. We've introduced some new APIs related to transportation and route finding. So WRLD has always had a representation of the road and rail networks that we've streamed in as part of our maps. But now you can actually access that in your app. So for example, you can, from any point in the world, get the nearest point on the transport network, and then you can run routing queries over that network, so you can navigate your users from point to point across the world map. And as Fazan said earlier, what WRLD provides is not just a 3D map in terms of geometry, but it's a semantic representation of the world. So all of the objects that appear inside your indoor maps can have metadata associated with them. So we provided an indoor map entity informations API, and so that allows you to access that metadata, so you can see what objects are there in your map, and then you can interact with them programmatically through the API. So that's most of the major features. What we're going to do now is move on to show you some demos. So if you just skip on a couple of slides, Fazan, thanks. So what we're going to cover off today, first of all, we're going to show you some of the indoor mapping functionality. I'm going to show you our updated VR and AR samples, talk a little bit about how you can use WRLD in an AI context, and then run through a quick tutorial for building an app from scratch using the WRLD SDK. Okay, so I'm going to screen share now. Fazan, you'll need to, yeah, thanks. Okay, so first up, we're going to talk about indoor maps. So one of the great features of the WRLD platform is not only can you build mapping experiences using our maps, but you can also add your own indoor maps. And now using our asset tool, you can add furniture to those maps as well. So what we're going to show you here is how you can, in a Unity app, you can add furniture and have it dynamically displayed in your app at runtime. So here we've got a simple WRLD Unity app running in the Unity editor. In this app, we can navigate around the map as normal, and we can also go inside this building here where we've built an indoor map. This is the WRLD Dundee office. So if we look around in the building, we'll see that all of the map features have been built and are displayed. And we can look around, but there's no content inside the map in terms of furniture. So recently we introduced the asset tool, which is an addition to our indoor map tool that allows you to place furniture inside your indoor map. So I'm just going to show you how that works in integration to a Unity app. So if we step into the indoor map tool in our browser here, we've opened up the same indoor map here, and all we're going to do is add some assets. So there's a full tutorial on how to use the asset tool available on our YouTube channel and website, but for now I'm just going to add a couple of desks here to the indoor map. So add a large conference desk and a couple of smaller desks. Okay, so now those desks have been added, and we're going to publish those changes. So all we need to do here is click Publish Assets, and this set of assets here has now been made live in our indoor map. So if we switch back to the Unity app, all we need to do is to step outside, and then the next time we enter the building, the assets will appear automatically. And there they are on the second floor, the conference table and the two desks. So that's all there is to it, very simple. And it also works with apps built with our other SDKs for JavaScript and for mobile. Okay, so I also wanted to talk a little bit about VR and AR. So we'll start with VR. So you already saw the Wings game that Fazan showed, which was built with the older version of the Unity SDK. So we've had VR and AR support since the earlier releases, but we've been updating our AR and VR support to match Unity's new XR framework. So this is a video taken from our VR sample app. You might recognize the location as being the roof of our Dundee office that was shown in some of the earlier videos. And you can see here as the user is panning their headset around, they can look around in a first-person viewpoint on the map. You'll also see that there are some objects suspended over the map there. So when you build a WRLD app in Unity, you've got a fully featured Unity environment, and you can introduce your own game objects into your scene. Similarly, with our AR sample, so here we're using plane detection to pick up a plane in the camera's view to display our map on. And using the same idea, we've got the WRLD map shown here on that surface plane that we can move around by moving our camera around, and we see that the viewpoint is updated. And likewise, we've got these additional objects hovering over the map, and you can see that as we move the camera in and out, we navigate around. So these AR and VR samples, they'll be getting updated onto our GitHub site very shortly, so you'll be able to set up an AR or a VR app for yourself using the new Unity SDK. Next, I want to say just a little bit about AI and machine learning. So this is a topic that we've got quite excited about. So since earlier on this year, Unity released their ML agents framework. So this is a pretty general purpose toolkit for training machine learning models. And as we played with it, it's clear that one of the sort of challenges for training any neural network is having a realistic environment to train it in. So given that we've got the capability to deliver streaming real maps of the world into a Unity app, we thought we would try and bring together WRLD's SDK, providing maps with Unity's ML agents framework. You might be familiar with one of their demo examples, which is called Rollerball, where an agent gets trained to balance a ball on a flat surface. Well, what we've done is we've adapted that example so that we can train the agent to basically move or roll this ball towards a target on the world map. So it's a very simple example, but just really shows you how to integrate these two frameworks and train a neural network. So I'm just going to show you how that works. So this is our Unity project set up. We have the WRLD SDK imported and also the Unity ML agents package. We've added a world map object to the scene with our API key. Then that will stream in all the world map resources when we start the training process. We've added a target game object. So this is very similar to the ML agents rollerball example, except we've added a positioner script which correctly positions the target on the surface of the world map terrain. And we have our agent ball, which is a sphere that can roll around on the terrain. All of the parameters that configure the learning process and describe the space which the agent's going to explore are here. And we've linked up the target object so that it knows what it's trying to navigate towards. So the script we've attached here also includes the world positioning to correctly position the agent on the surface of the world map. Once we've got all those things in place, then we can run training as normal. So we can see here, for example, at the start of the training period, generally speaking, the agent doesn't find its way to the target before the 1,000 steps cutoff is reached and it gets respawned. But over time, it gradually learns better how to navigate to the target. So the episode length decreases and correspondingly the reward increases. So here's a snapshot of the training process running. So we'll see the ball moving around the world map. At this stage, it's relatively early in the process, so it's moving quite randomly as it explores around and learns how to gain the maximum reward. And we'll also see that after a period of time, it disappears and respawns at a new location. So we're going to be putting out a blog post covering how to set up the ML agents framework with WRLD shortly. So I think this is really just scratching the surface of what you can do once you've got a WRLD environment up to train your machine learning model in. So we're really looking forward to seeing, what people are able to build with that. So the final piece of content we want to go through with you guys today is our flight sim tutorial. So a couple of weeks ago, we launched a step-by-step quick guide on our website that said, you can get started building a simple flight sim game in Unity using the WRLD SDK in under 30 minutes. Well, today we're going to run through the basic steps of that from scratch, showing you how to get started up to having a working flight sim. And it'll take about 10 minutes to go through. Obviously, if you're doing this by yourself for the first time, have to download everything, then it might take a little bit longer, but hopefully you could get something up and running within the 30 minutes. Hi, we're going to walk through the whole process of creating a simple flight simulator using the WRLD Unity SDK. This tutorial is also available as a step-by-step quick guide on our website, so you can follow along at your own pace. You're going to need the Unity editor, version 2019 or 2020, and a copy of the WRLD Unity SDK version 0.8. You'll also need a WRLD game development account. If you're not already a subscriber, you can sign up for a free trial on our website to get you started. So the first thing we need to do is to create a new Unity project. We're going to use the 3D template and we'll give it a name, Flight Simulator. While Unity is starting up, we're going to go and retrieve a World API key from the World website. Every app that you build with Worlds requires an API key to authenticate your app with our services. You can create your own API keys in your own account on the website, and then you'll copy them into the app. So we've got that in our paste buffer now, ready for when we need it. So now we've got our project set up, we need to add the WRLD SDK. We do that by importing a custom package, selecting our Unity package, and going ahead with the import. During the import process, we'll see a couple of prompts come up. First of all, a reminder to go and create your API key if you haven't already done so. We've already got one of them. If not, you can click Get Key and it'll take you to the right place on the website. We also see a prompt about shadow distances. So world maps typically cover a larger range than most game environments, so we recommend increasing the shadow distance setting. Okay, that's the World package imported into the Unity editor. So now what we need to do is add our API key into the configuration. So if we look for the Unity world scene, which contains a world map object, and we can paste in our API key. Now that we've done that, that's everything that's needed to get a basic WRLD Unity app up and running. So we can press play in the editor and see what it looks like. As you can see, the app's displayed part of San Francisco, and the map is streamed in. We can move around, and as we move, zoom out and move to different areas, more map resources load dynamically. So let's stop the app for now, and we're going to save our progress. And we're going to save this as Flight Simulator scene. Okay, so now we've got our basic map. In order to turn this into a flight simulator, we need to add an aircraft. So we have a pre-built aircraft model and textures that we're going to use, and we're going to import that into our project and add it to our scene as a Unity game object. So first of all, we want to import the aircraft mesh. So in the set of files that we've downloaded that are available for you if you're following through as well, and we'll select the SpaceJet Collada file and import it. And we can see that it's been added to the set of project assets there. So we're just going to take the mesh, which is this one here, and we're going to drag it into our scene. We'll call it aircraft. It's a flight simulator, although it is a SpaceJet model. And we're going to change its default position. So we're going to set it to Y 500 and Z of minus 500. And so the WRLD SDK uses meters as its units. So this is 500 meters off the ground in the Y direction and 500 meters in the Z direction, so it appears correctly relative to the camera. And we're going to set the scale to 5 in each dimension. So now when we start our app, we'll see the model appear in the correct position above our scene of San Francisco. So now we want to also add a texture to our model to make it appear a bit more realistic. So again, we're going to import the texture file that we've got here. And we're going to use it to build a material that we're going to apply to our model. So here's our new material. We're going to call it Spacejet Material. And then we're going to select the texture file that we imported. And there we go. And finally, we just need to apply that material to the aircraft. So if we select the aircraft game object, and we're going to set it as the material to use for the mesh renderer. Okay, so that's all set up now. And when we press play, we'll see that the texture has been applied to our mesh. Okay, so the next thing we want to do is to add some simple physics to make our aircraft move. So we've got a flight controller script which takes inputs from the player and uses them to control the aircraft. So the first thing we need to do is to add a rigid body so that we have so we can apply the physics. Forces, including the forces that our controller is going to add, and also gravity. So we just add component here, and from the physics group we're going to add a rigid body. And then we're going to add our controller script. So we have a pre-built aircraft controller script here, which we're going to import. And we're going to add it to the aircraft game object. So you'll see it appears here at the bottom. There are a few parameters that you can play with, like the thrust force, the turn force, and the maximum speed. So this controller takes input from the player, either the cursor keys or WASD. So now if we start the app, we'll see that we can control our aircraft as shown, and it will fly around the environment. Eventually it's going to fly off, out of scene. So the next step in the tutorial is going to be to control the camera so that it follows the aircraft. So again, we've got a ready-made script as a camera controller, and we're going to import that into our project. So all the camera controller script does is it sets the camera location to follow the target game object, which in this case is going to be our aircraft. So we're going to drag that onto the main camera, and we'll see there that it's appeared in the inspector. We want to set the object to follow to be our aircraft. And there are a few parameters such as the position of the camera relative to the object, and the bias, which tells the camera how quickly to adapt to changes in the position. One final step, we need to disable the built-in world map camera controls, which we use to manually navigate around the map. So if we go into the world map game object, there's a toggle here, use built-in camera controls. We're going to turn that off. And so now the main camera is going to be controlled by our script. So let's start. And we'll see we're now in a kind of third-person view with the So we're going to finish the tutorial there. The quick guide on the website has a number of optional extension exercises that you can choose to go on and modify based on what we showed you here, such as adding different locations around the world map, collision detection, pickups to build the basics of a game, or modifying the aircraft behavior. Okay, so that was maybe just slightly over 10 minutes, but hopefully you'll agree it was pretty straightforward process if you want to follow it yourself to get a basic Unity flight sim game up and running with WRLD. So that's everything that I wanted to show you in terms of hands-on and tutorial demo content. So now we're going to go back over to Fazan to go through Q&A if anyone has any questions.
All right. So we've been getting a few questions in. A few of them we answered, but a lot of really good questions. So let me just go ahead and pull up here. So if we, so one question coming in from Noman is, if we need to create our own map of any local city, can we do that? Ian, you want to answer that?
Yeah, so essentially, WRLD has, and you can find our coverage on our website, certain areas of the world that we have covered, and there's others where we'll add coverage in future, depending on users' interests. So one thing you can do there is just go and register a vote for the areas of the world that you'd like to see added to the world maps. The other thing we can do for commercial customers is we can look at adding specific regions of the world. If you've just got a small area that you're interested in us adding or updating, we can do that. So if that's the case, just drop us an email and we can look at getting that added for you.
Great. So the next question is from Amir, who's asking, how efficient does WRLD run for VR? And is it possible to hit 90 frames per second in flight sim? So maybe Ali, maybe you want to answer that, or Ian?
Sure, I can take that. So it's very much reliant on what the VR device you are using is and what the view is showing up. So for example, if you are running it on Oculus Quest, then that's an Android device. So it's probably not gonna hit that performance benchmark if you're flying up high. But on a Windows machine, it can. It's why, like, if the machine has that performance requirements in it, and less meshes, so you will get better performance out of it. But if you are very far up and you are drawing a very high draw distance, then obviously that will be a performance hit. And it's not really just world map. Any 3D meshes of a large area with a large draw distance and high LODs will do that to any VR experience. So just like any other VR experience, same optimization techniques apply to world maps as well.
Great, thank you. So the next question is from Haris. So once we've got the world map imported in Unity, can we customize the buildings according to our game scene requirements? Does this map contain a digital twin of the city?
Yeah, so thanks for the question, Harris. So basically, when you stream in the world map, you're getting the landscape, you're getting all the buildings there as well for the regions that we have covered. You know, if you want to modify those, you know, certainly it's very easy to add additional features. So you can add your own 3D models and place them into the environment if you want to. If you do actually want to modify the mesh, I mean, that is possible, but it's quite technical because we stream those meshes in and dynamically update them. You do have control over the textures, lighting, and any effects that you want to add. So I think we had a example where we turned one of our sort of cities into a sort of Blade Runner sci-fi kind of visualization. With all the sort of moody lighting, rain effects, dark sky, floating billboards, that kind of thing. So it is possible, and you can find some of those videos on our YouTube page or on our blog.
Great. So another question from Krishnan, and feel free, everyone can sort of weigh in here on the panelist side. But to get a better understanding of what the ML agents can do in World, what are some real world examples you can imagine we can do with ML agent support in World? So I'll take a stab at it first. Very excited about the ML agents framework. I think there's a lot we can do there. One of our key focuses around smart cities, and one of the things that we think we can be able to effectively do there is simulate things like pedestrian flows within a smart city based on how you actually do some of the city planning and urban design. Something that would be quite relevant right now is around COVID transmission as well, based on those sort of pedestrian flows there, what the transmission looks like. And we're doing some very interesting work with the Center for Disease Control right now, who's looking at using the platform for some simulation efforts. So flood detection, that's another one that we've talked about. And some of the use cases that you saw discussed in the Udacity video, we think those are quite powerful. So autonomous vehicle simulations, one of the challenges with autonomous driving today is that I've read reports where you need billions of miles of drive time to reliably depend on autonomous vehicles. And I think to date, we're still in the probably in the tens of millions, maybe hundreds of millions at best at real drive time. So using platforms like World, can you simulate road conditions for your autonomous vehicle algorithms? Those are some of the types of use cases that I see possible with the framework demo, but Ian, Ali, Bilal, if you guys have any other ideas, please chime in.
Yeah, so I think one of the areas that can get really interesting with this stuff is once you introduce multiple agents into an environment, allow them to interact with each other as well. So for example, you could train agents to act like people in a crowd. So they have maybe they're all trying to navigate from one area to another. If you place many of those agents into an environment, you can start to do scenario planning, like how long does it take to evacuate a certain number of people from a space, or for example, in an outdoors, if your agents are traffic, if for example a road is closed, how does that change the dynamics of how traffic flows around your city? So you can start to do those kind of scenario planning types of simulations as well.
From my side, what I found most interesting in ML with World 3D is that since you have a whole map there and it's geolocated, so you can do anything with any lat-longs. So any machine learning use case that you would use with any other map can also be used with World Map, but we have an edge there there because any other map is just a flat 2D plane, but we have that verticality in there. We have 3D buildings, we have real world scale. So when doing machine learning, say you want to train a drone to fly over buildings, you can't do that in a flat map. But since we have that height data, you can do that in world map. So that's one of the edges that we have.
Great. Thank you, Ali. So the next question is, can the indoor maps you use with Unity be used by the other SDKs? I can answer that. Yes. So indoor maps and the assets that the asset tool that Ian showed you earlier, that's available on iOS, Android, and also on the web, in addition to Unity. So, you know, as we mentioned, it is a build once, deploy everywhere model. So if you start using the WRLD SDK or the WRLD platform on the WRLD site and start creating content there, that's going to be available across all of these SDKs. So what I suggest is, Usman, why don't we take it offline? If you send us an email at support@WRLD3D, we can give you some guidance there. But effectively, I assume you want to get a Unity, you want to get Unity up and running first, and they also offer a lot of tutorials there. But you know, we're happy to help you and give you some guidance there. Are there any other questions?
So there's a follow-up question here from Harris. So he's asking if I want to build a sort of micro level scene, can I place my own textures on the world building? Yeah, so we do have multiple you know, levels of detail in our mesh. You know, I would say because they're designed to stream in. You know, we don't have really high detailed models in there, but you can, you know, zoom right in. You know, for example, for the sort of VR type experiences where you're want to be in a first person view, you know, you can get right in up close to the terrain and to the buildings. So, you know, if you're wanting to build an app that's concerned, you know, with a very small area that you want to, you know, bring in your own textures and apply them onto the mesh, you know, absolutely you can do that.
Great. So Amir also has a follow-up question. Is it possible to download one area from World Map and combine meshes and perform other optimization techniques?
So I'm not quite sure what you're getting at there, Amir, but essentially, I mean, the WRLD SDK will dynamically stream in the map resources, so the mesh geometry, depending on what area you're looking at present. So it's not really possible to, you know, kind of download the map and, you know, use it in some kind of sort of offline mode and modify it, I think, in the way that you're thinking of. You know, you just basically point the camera at a given you know, pose, and then WRLD will supply the resources to fill that view for you for your app.
Great. Mike Oakes, you've got a question. Will we be posting the meeting link? We will. We'll certainly be sharing that after, probably by tomorrow, we'll go ahead and share that. So if you registered, you'll definitely get you'll get access to it. Okay, any other questions? So I've got a question from Noman Fall. Is the available map, will that be available in real time? So the actual map is not in real time. So we run a build process to build that mapping data. But effectively, what the beauty of what WRLD does is it's a great platform for then overlaying real-time data on top of it. So we work with all types of different kind of data sets, from vehicles and telematics data to indoor positioning and HVAC type systems, a lot of different sensors. They've all been visualized in the world environment. So, certainly while the map is a sort of point in time, the data that sits on top of it can certainly be real time. Okay, I think, great. Hopefully we answered all your questions. Thank you, everybody. We just want to reiterate how you can get up and running. You can sign in or sign up at world3d.com. We offer a free trial of the game development plan, which is going to give you access to the Unity SDK. And if any questions arise, you can email us at support@world3. That goes directly to our platform team. Or you can respond to us on a chat bubble that's featured on basically most pages of the website. So we're really excited. We thank you for taking your time today. And we will be not only sharing this, but we'll also be sharing a survey where, if you've got some capacity, it's a quick survey. We'd love to get your feedback. We'd love to understand what else you would like to see within the platform, not just in Unity, but within World. We're always looking to better understand that. So thank you, everybody. We will be having more of these, so appreciate you joining us today. And if there's any questions that we missed, once again, you can hit us up at support@world3d.com. I see a quick question here on how I created, how we created my avatar in World. That is, Ali, do you want to give a quick view into that?
So there are multiple things going on with the avatar. One is a 3D model that we created, and we positioned it in an indoor map and the outdoor map using the positioners that you can use in Unity 3D. For the avatar that's getting animated, we used the AR capability that does the face tracking, and we applied it to a custom created 3D model of Faizan. So Faizan could just look at his phone, and his phone's camera would record his face and apply those expressions to the 3D avatar.
Yeah, if that's something interesting, then definitely for a following webinar, we'd love to show that. It certainly was fun to play around with that. So yeah, happy to share that. Thank you so much, and we look forward to hearing from you soon. Thank you, everybody.
Thanks, everybody.